Okay, so we have the GIS process. Some love it, some hate it, but most of the time it's definitely a combination of a love-hate relationship. There's a lot of problem solving and looking for a solution, which can be frustrating but very addictive at the same time. But most of the time, in the end, your result is going to be rewarding and can contribute to all sorts of decision making and progress. So we have this chart here, and so the first part of the chart, this chart is going to help formalize how the GIS process works from start to finish, and it'll involve what steps are in that GIS process. So the first thing that we have here are questions about the physical world. So questions should be spatial in nature, otherwise we don't really need a GIS to analyze, and we could analyze our data in Excel or Access. And so an example of a question or a spatial question would be, how many agricultural parcels are within 200 meters of a stream and where are they? Hydrologists might notice high levels of mercury content in California streams. Where are all these streams in relationship to abandoned mines? Is there a pattern, etc.? So the next step we have is to define protocols. It's especially important in large organizations where multiple people are working on the same project. It's important to be consistent about how you're analyzing the data. Even when you're working alone, certain things you want to establish ahead of time. This is extremely helpful later on when you want to share your work or if there's any issues that come up. So make sure you define those protocols at the beginning. The next thing that you would do in the GIS process is to collect, create, or edit spatial data. So as we know, there's no initial data in a GIS. You have to go get it. Whether you find it off the internet, get it from a client or class you're working in, or if it doesn't exist, you have to create it. The next step is the star of our show today, spatial analysis. In particular, spatial analysis is the use of one or more spatial operations to solve a problem or answer a question. There are hundreds of spatial functions and operations used in geospatial analysis. In this class, we're only going to go over a few of them, which we will get to shortly. So the next step in the GIS process is create output report results. So we have the possibility of creating statistical information, charts, final map images, geospatial models, reports, and much more, which will then lead to the final step of making decisions and deciding how to act. So in a study where the first step is to determine spatial distribution, I would like to visualize, for example, the distribution of salamanders in a certain area. So some of those questions that I would ask for a spatial distribution question, we want to know, where is X? Is it grouped or dispersed? So are the salamanders grouped together? Are more dispersed? Are they all found in a certain bioregion? So again, where is X? Then my second step is to determine the relationship. So the relationship is between the spatial distribution of objects or themes. Where is X in relationship to Y? So for example, where are my salamanders in relationship to wetlands? Do all of my salamanders occur within a certain distance of a wetland? Another example is the association of objects or themes in an area. Is there a correlation between the distribution of X and Y, and could X be causing Y? So a question I could ask there is there a relationship between water quality and size of the salamander? In the most basic form, executing spatial operations usually involves a map layer input and a map layer output. A map layer is a visual representation of geospatial data in GIS software. Solving a problem often requires a chain of spatial operations executed in a sequence. So if we were to diagram out any spatial analysis, it would look like this. A series of spatial operations is performed in most spatial analyses, so it really helps to create a flowchart with expected layers, spatial operations, and outcomes to organize your methods and process to move forward. Part of the challenge of geographic analysis is selecting appropriate spatial operations and applying them in the appropriate order. This chain sequence becomes easier over time once you become more familiar with all the spatial operations and functions in a GIS. The table manipulations that we covered in the last lesson are included in the Bolstad definition of spatial operations, so that includes attribute queries, location queries, etc. In fact, many operations incorporate both the attribute and coordinate data, though there are some differing opinions based on the fact that an operation might be applied only to the non-spatial attribute. Bolstad argues that though that may be true, attribute data are a part of the definition of spatial objects, and it seems artificial to separate operations on attribute data from operations that act only on the coordinate portion of the spatial data. So as we can see here, with this chain, we would have our input layer, we have our first operational operation, the output and the creation of the first new layer, we have a second spatial operation, we have our second new layer or output, third spatial operation, and then our final layer and output. So this is an example of a sequence chain. And so I'm just going to go through this really quickly just to give you guys an idea of what the thought process is here. So here we're looking for gnatcatcher habitat suitability. So we have a lot of questions that we want to answer. And so the first thing that we want to do is we have our first input layer. So we have our major roads and input vegetation, and then we have our spatial operations here. Here we have a buffer, so we're going to buffer rows using a distance field. And here we have a select operation, so that's one of those attribute queries. So select suitable vegetation types. And so it's going to, each of these spatial operations are going to give us an output. And so we have our roads buffer and our suitable vegetation output layers, which we are then going to apply a spatial operation of erase. And so that erase function is going to erase buffer zones from the suitable vegetation, which gives us another output layer, which then we can see here is being combined with 3 additional input layers, which then goes to an intersect spatial operation and so forth, all the way until we get to our final output layer, which is that potential habitat for gnatcatchers.